So thank you for being here. I'm going to talk about solid-state drive technology, why they are so important within the Nexenta implementation, why we differentiate between enterprise solid-state drive and consumer solid-state drive, and what you need to know about those two different markets and products. So first of all, let me just start with very few words about who we are. STC is not very well known in the channel business because up until now we've been very much focused on OEM business. If you look at all the major storage appliance and server from the big guys, most of them, they rely on our SSD since the beginning of the SSD era. So the company is 20 years old, and we engaged in enterprise business in 2007. We were the very first one in that market. So we are ranked number one today in terms of volume and revenue by IDC in the enterprise business. We have been the very first to market with a single-level cell enterprise SSD, and also the very first one with enterprise multi-level cell. The first deployment in a big OEM has been together with IBM. In terms of innovation, we differentiate from most of our competitors in the fact that we develop our own technology. So all the controllers, the firmware that are on our SSD are developed internally by STC. And we have the widest product portfolio. I'll give you an overview later on. I just mentioned we are very famous with the OEMs. You see here all the major storage players in the market and server manufacturer. We are now bringing those products to the channel. So this is something really new. We started 1.5 years ago together with Nexenta, thanks also to Nexenta. And now we are extending our presence in the channel business. So let's come to the topic of this speech, why we need to differentiate between enterprise SSD and consumer SSD. So what makes really an SSD enterprise ready? So there are three topics that we need to look at. Performance, it's the key word in this market. So our customer, they don't buy the SSD because of power consumption. They might, but that's not the reason. They buy the SSD as a cache or as a tier 0, and they want to write to the SSD and write fast and make sure that the performance do not degrade. Endurance, flash, unfortunately, is limited in number of program erase cycles, how many times you can write to the flash. So enterprise SSD deploys some features to extend the endurance, while you don't have those features on a consumer SSD. And reliability, so you want to make sure that the data you write, the data you read are the data you wrote. So let's talk about performance. If you have experience with SSD, you know by effect that the SSD degrades over time. And if you start writing in a random fashion and you fill up the drive, this degradation gets even worse. So I've been searching, when I was preparing the slide, I was searching for some independent data, because if I give you my data, then you don't trust me, and you shouldn't trust me, actually. So I was looking for data from the web, and this is what I found. So here you have a benchmark of different consumer SSD. So those are consumers. Some of them claim to be also enterprise. It's very interesting to see that when you get a fresh SSD, all of them, they are extremely fast, extremely fast. So buy whatever SSD if you want to use it just for 1 day. But then if you fill it just 2 times, so here it's just 2 times, then the performance get the ratio is 5:1 in terms of performance. So you lose 70 to 80% of your performance when you fill it 2 times. And that's not me. This is not from STC. You can find this article on the web. And then if you leave it idle, maybe recover a bit. And if you play trim, then it recover even better. But what is trim? Why do I need to play trim? Trim is just a technique to overcome a limitation on the flash management. So Intel is telling you that you need to have trim on the SSD just because Otherwise, you will get performance degradation. If you have the proper flash management in place, you don't need to do any trim, and you don't want to do any trim on a server because you need to stop operating the server. So you won't see any performance degradation on our SSD. The number that we publish on our datasheet are the number that you will see over time, over the warranty period. And actually, I want to show you also this other graph that has been done by one of our customers, Company O, guess what? With 3 different types of products, SAS, SATA, and PCIe, compared to our entry-level Mac 16. So you see by the graph that after 1 hour, this is 1 hour operation, the performance gets nowhere close to what they declare. And our entry product, it's much more performing than their highest-end PCI Express device. So that's the way we differentiate between enterprise performance and datasheet. Let's talk about endurance. Flash wear out. So the more you write to the flash, the less the lifetime of the flash because of physics, because of the degradation of the cell within the flash. So there are, on the other hand, if you are building a storage appliance or a server, you want to use it 3, 5, even more years. So you want to get more endurance out of the SSD. So we came up with what we call cell care technology. Cell care technology is a proprietary technology of STC that allow us to extend the endurance by 20 times. So this means that we can now deploy cost-effective multi-level cell flash in an enterprise application. So how this really translates to you, we are able to give you a warranty, and it's a real warranty, it's our liability. You can write to this drive 10 times per day all the capacity of the drive for the 5 years warranty. So for a 400 gigabyte SSD, you can write 4 terabytes of data every day for 5 years. So if you compare this with a consumer SSD and also some enterprise SSD, there are 2 orders of magnitude of difference in the endurance. And it's our liability, so it's not just an acronym, it's not just a marketing name, it's our liability, it's a warranty statement. There is another easy way to overcome the endurance limitation. Flash wear out, DRAM doesn't. So we could use DRAM on the SSD instead of flash. And this is actually what we are doing on the Zeus RAM. Some of you are already familiar with the Zeus RAM. The Zeus RAM is a 3.5-inch SSD based on 8 gigabytes of DRAM with a SAS interface. So we get the standard interface with the performance of the DRAM, but this DRAM is fully backup on flash. So within the drive, we have supercapacitors that allow us to flush all the data to the flash in case of a power loss. So we have persistency of flash, non-volatility of flash with the performance of the DRAM and with the unlimited endurance of the DRAM. And this is actually the perfect device for the ZIL cache, because on a ZIL cache, you keep on logging data in a very small file 24/7 all the time. So that's very stressful for the endurance. And by having a DRAM-based SSD, you don't need to worry about any wear out. And finally, let's talk about reliability. The way we assure reliability is through 3 different techniques. One is the data path protection. So we apply error correction all along the drive wherever there is memory and flash. We also develop what we call SAFE. It's another acronym standing for a secure array of flash elements. It's a RAID at the end of the day. So on our drive, if you buy the 400 gigabyte, in reality it comes with 512 gigabyte of raw flash. Some of these use for the RAID, so it's a RAID 15. So these allow us to recover data even if we get a flash failure, which is a catastrophic event. So, and this is transparent to the user, so there is no degradation in performance, no degradation in capacity. Why did we come up with SAFE? SAFE, we believe it's mandatory for sub 2x nanometer technology. So flash shrink. So the flash vendor, they tend to move to a more aggressive process geometry every 18 months, roundabout, to save money, to make it smaller and cheaper. And the more you shrink, the less endurance you get and the less reliable it becomes. So by adding SAFE, by adding RAID into the drive, we're still able to commit to 2 million MTBF on the SSD. And finally, we always have a power-safe technology. Most of the time, it's done through supercapacitors, and actually, this is one of our fundamental patents. So on the SSD, we always have some DRAM, and this DRAM is backup on flash through those supercapacitors. Few words about, just one slide actually, not few words. Just one slide about our product portfolio. We differentiate product by performance. I said at the beginning, we have the widest product portfolio. It starts with entry-level products. Used to be very much compact flash focus. Now we see a lot of traction for slim SATA for booting. So use as a boot device on a server or on a storage appliance. The Zeus IOPS with the fiber channel interface. Fiber channel is becoming less and less popular. We still have some customers using fiber channel, but most of our customers, I would say 95% of the new design are already on SAS, at least on the storage side. On the server side, there is a lot of demand for SATA. In terms of SATA, the product that we promote, it's called Max 16. It's based, again, on our ASIC, very similar architecture to the Zeus. The difference between the Zeus and the Max 16 is the interface. One is SAS, the other one is SATA, and the performance. With the Zeus, we can get 3 to 4 times more IOPS out of the products. And on top of this, we are in process of releasing our PCI Express device. I welcome you to stop by our table to see the demo of the PCI Express. It's a new product for us. It will be available for the channel starting by the end of June with 2 capacity, 480 gigabyte and 980 gigabyte with MLC technology. Same technology that I already described, so the cell care, the safe technology, the power save technology on this device. You might be familiar with the major player of this market, that is Fusion IO. The way we differentiate with Fusion IO is by the fact that all the flash management is done on the card itself. So on our controller, we do all the flashware leveling. We take care of the PCI interface. We take care of garbage collection and whatever it takes to extend the endurance. So what it means for the user, it means that you have far less taxation on the host CPU and the host memory. So the Fusion IO card fully rely on the performance coming from the CPU of the host. In our case, the performance comes from the ASIC that is on the card. And at the top of the pyramid is our Zeus RAM, so the product that is used for the ZIL cache. On top of the hardware, we're also selling a small piece of software, which is not competing at all with Nexenta, but it's just complementing what Nexenta does. Today, you can have a very fast storage system, thanks to Nexenta implementation, thanks to the ZFS. And the SSD usage, but the access to the data to the storage is limited by the connection. So the idea of the caching software is to cache the data on a server by using one SSD on a server that can be a PCIe, can be a SAS device, can be whatever type of device, and use it only as a cache. Can be caching read, and by the end of this year, we will also add caching write. So we call it Enhance IO, and it's a software that you can download free of charge for a demo for 30 days on our website. It's not yet GA, so it will be general availability by the end of June once we launch the PCIe. Let me just recap 1 second on the technology. So we mentioned about the key differentiator of STEC are cell care technology, the ability of extending the endurance by 20 times, and as a matter of fact, we can provide multi-level cell flash SSD with the endurance of SLC solid-state drive, so much more expensive SLC solid-state drive. The advanced flash management, the data path protection, the power safe in case of power loss, and the safe technology. Let's dive into our cooperation with Nexenta. As I said at the beginning, we started, it was almost 2 years ago. I met Andy at one show here in Germany, actually not here, but in Germany. And he was very excited about this product, the Zeus RAM, that we were in process of releasing. The typical configuration that now Nexenta is proposing is to use the Zeus RAM as a ZIL cache. So take advantage of the very low latency and take advantage of the unlimited endurance of the DRAM for the ZIL, and then get the performance of the L2 ARC of the cache through the Zeus, again with SAS interface. Most of the deployment we see are with the 2 Zeus RAM for redundancy reason, and 1 or 2 Zeus IOPS as a read cache, but these heavily depend on the performance that you need to achieve. So there are a deployment where you have 2 Zeus RAM and even 10 or 12 Zeus IOPS, depending on the performance required. So we have been very successful with the Zeus RAM. Most of the Nexenta folks knows about the Zeus RAM and use already the Zeus RAM. And now we want to capitalize on this, and we want to make sure that every SSD in the box will be STEC SSD. So since we are known to be expensive, we came up with bundle pricing, and we are offering now a significant discount whenever you buy the Zeus RAM together with the Zeus IOPS multi-level cell. This way, we know about many customers using the Zeus RAM for the ZIL and using low-cost SSD for the L2 ARC. By having this bundle pricing strategy in place, you can get the L2 ARC from STEC at a very similar price of consumer L2 ARC, still with the reliability, endurance, and performance of STEC product. And let me stress the importance of the L2 ARC. Just before the conference, we came out with a press release, and we were asking for user case, and we got this nice statement from one of you, from Edo at BAS Group. So where he clearly stated that he has been trying using a lower cost SSD for the L2 ARC, but this was degrading just after 2 months, and he had to switch over to our technology, and he doesn't see any degradation after already some years of installation. Okay, let's look at some of the benefit that you will get by this type of configuration, by having a Zeus RAM together with the Zeus IOPS in the same box. So we are benchmarking 2 types of system. One system that is hard disk only, so 22 SAS 6 gigabit device in a RAID mirror. And the system in blue includes also a Zeus RAM and a Zeus IOPS. So what does it mean for you? At the end of the day, by adding those 2 components, you get 5 times more performance in terms of input-output per second on a file server. You get something like 10 times more performance on a OLTP. And this is something like 20 times more random IOPS. Again, with a very limited investment, because 10 thanks to the bundle pricing, we're talking about a price that can range between $3,000 to $6,000, depending on the configuration that you select. With the same system that you have today, you will be able to serve 10 times more user. You will have half the response time, and the transaction per second will be 5 times higher. So if you think about the overall cost of every Nexenta installation, not only the software, but obviously all the hardware, this $3,000 to $6,000 doesn't add much, but it yields a huge boost in the performance. And just for today, just like at the supermarket, we have a special discount for you attending at the Open Storage Summit. So if you stop by our table, we have a voucher. Make sure you take the voucher. We give an additional $100 discount. Yeah, it sounds like being at the supermarket, but we like those things. And you can get the voucher, and you will get this additional discount because we want you to test the combination of the two products.
How many vouchers per person?
Just change your name on the voucher. Just say, be creative when you redeem it. Okay, last but not least, you saw in the presentation this morning from Evan that Nexenta is announcing an all-flash-based appliance. And this, I'm sorry. My mother, sorry about that. I shouldn't say my boss. So it's this all-flash-based appliance is today based on our Mac 16. So it's based on the lower cost product that we have, which is not a low-cost device. I mean, it's an enterprise class SSD used today in most of the time by the server guys. So the configuration that Andy has put in place includes 22 Mac 16 in a RAID 10. So at the end of the day, the overall capacity that you get from this 400 gigabyte 22 drive, it's 4 terabyte. In addition to that, there are some boot device for the system. All in all, Andy was able to achieve 250,000 sustained write IOPS. And that's amazing. I mean, if you compare it with the all-flash-based appliance, this is 2 to 3 times faster at a price that is much, much lower than what you get from people like Violin or Pure Storage or all of new guy coming to the market. Just to give you a reference, the cost of the SSD itself, it's not defined, but we are planning to give a bundle price for all the package in the range of $25,000 to the distributor. So the MSRP will be in the range of $30,000 for all the package. And together with Andy and Nexenta, we're also working on the next evolution of this device that will be using the Zeus IOPS. These allow us to go much faster. So we are targeting to double the performance to achieve to 500,000 write IOPS on this device. Will allow us also to double the capacity, so get an appliance up to 8 terabyte, and to double the price. So we are giving you the same price in terms of dollars per gigabyte for a much higher performance device. So this is to come. So I think it will take a few weeks to fine-tune all the bricks of this product. But it's a reference design that Andy is putting in place, and I'm sure that it will be available for all the system integrator quite shortly. And that's all from my side. So I think we have a great partnership, a great synergy with Nexenta, and we welcome you to test our drive and prove all my statement, all my marketing slides in a real environment in your application. Questions?
What's the operating system compatibility?
Today it's compatible with Linux in the Red Hat 6.0, 6.1 and CentOS, and also with Windows 2008 R2. We plan to have a VMware version, but this will be for end of the summer.
Solaris for BSD?
It's not in the roadmap right now. We are talking about this, but it's not yet committed.
We're talking for the PCIe card, right?
We're talking about the software in this case. We were talking, yeah, the caching software, yes.
The PCIe card?
The PCIe actually it's used the same driver today, so it's still Linux and Windows and VMware after the summer. There are more concrete discussion about Solaris, but it's not yet implemented. More questions? I still have 10 minutes, so please ask some questions. Go ahead.
Well, I guess your previous answer kind of conditions your next answer. But you would have gotten even more IOPS if you use L2ARC on the PCI Express cards. And I don't know about the ZIL. I don't know if with 22 SSDs you still gain something from an 8 gigabyte ZIL. But wouldn't you have gotten to IOPS with a 400 gig L2ARC or 800 gig L2ARC on a PCIe?
Yeah, that's correct. I mean, we selected the Max 16 because it comes with a 2.5-inch form factor, so it's a hot pluggable and a bootable device. PCIe would be a challenge in terms of integration, but for as L2ARC, I don't think Nexenta support L2ARC on PCIe. I think this is I wouldn't call it a limitation, but if I'm not mistaken, it's the way the software is designed cannot take advantage of PCIe. Yeah, but you are correct. In terms of pure IOPS, the PCIe deliver more IOPS than a SAS device.
Can you tell the difference between the Talos and the SUSE?
Yeah, okay. I think we saw something there. This one. In this chart, actually, don't tell anybody, but company O is OCZ, and the SAS device is their Talos. And if you look at the performance, this is done by one of our customers, so it's not developed by STC, this graph. If you see the performance degradation that you get on the SAS device, which is the red one, this goes after what is 2 hours of operation, you get from 35,000 IOPS down to, what is here, 3 hours, it's 5,000 IOPS, and it's getting lower and lower. So it's very simple on SSD to achieve very high performance. I mean, if you have a very simple flash management, you can go faster, but still, obviously, you lose on long-term reliability and endurance. What is very difficult is to maintain the performance over time. So if you go on our website, you can download a utility that allows you to precondition the drive, so to fill the drive with random data, and make sure that you randomize all the information within the drive. And after that, you can start your benchmark, can be IO meter or whatever. Actually, on our website, we have also a SSD-oriented version of IO meter that you can download, and you can try to run the benchmark. If you compare a OCZ Talos, a new OCZ Talos with our any product, let's say the Zeus SAS, it will show much better performance for the first 30 minutes. And then the performance get nowhere close. Look at this chart. This one is the Max 16. It's a SATA device. So if we were to benchmark together with the Zeus IOPS performance would stay flat over here. Yeah?
Are we going to see that? Is that one of the things that you're warranting across 10 writes across the entire device?
Yeah. It's a warranty statement. So we give you the 10 writes per day for the 5 years. So you have a counter within the smart parameter where you can check how much you have been writing to the device, and you can understand. So if you send us back one drive and you say it doesn't work anymore, and we check this parameter. Okay, you wrote too much, fine. If you didn't write too much, then it's our liability. You get a new one.
Are we going to be seeing that level of non-degrading performance?
You will see this stability of performance. I mean, sure, you will see a degradation at the very first time, but once it achieves stability, it's sustained performance, so it will not degrade over the 5 years. Yeah. And that's the major challenge. I mean, we have been shipping solid-state drive in the enterprise since 2007, and at the very beginning, I remember that it was very challenging to keep stability of performance. So it took us here to optimize the firmware and to optimize it in read, write, and random, and to keep it stable. So it's not a trivial exercise to make it.
But when it's so demonstrable that it tails off so quickly, why aren't your competitors doing this?
Cost, because this costs a lot. I mean, if you consider, if you want to keep performance stable, on flash you cannot overwrite. You always need to erase before writing. So it takes time. Once it's filled with random data, you need to erase a block to be able to write a page, which is a small portion of a block. And this slows down dramatically the process. So the way we keep performance stable is by doing over-provisioning. We always have more flash than what the user can see. So we always have empty block at any given time. So we don't need to wait to erase a block before writing. We always have empty block that we can use. And this helps us keeping performance stable. But at the end of the day, dollars per gigabyte, we are competing with a 400 gigabyte device against a 512 gigabyte device. So it's more expensive if you look at it dollars per gigabyte. That's one of the tricks. Obviously, there are many more. Otherwise, you have all the secret sauce now.
Have you ever tested performance degradation with, for example, the LSI SATA controllers with the fastpath firmware? Because that should also make the degradation less.
Yeah, I believe you. I'm sure that's the case. Honestly, I don't remember seeing any benchmark data on this. Yeah.
There's also an option to do, right? Just flash your SATA controller with the fastpath firmware, which is really specialized for SSD for controlling SSD.
Yeah, that's true. But let's say what we do, it's on our side. So our firmware is already optimized to keep performance stable. So you don't need to add additional layer. Yeah. You can. It will not hurt, but it's not required. Yeah.
But this performance degradation on your competitors' drives, you're assuming a non-trim operation.
Absolutely.
Yeah, because you have garbage collection in the chipset. Okay.
But do you want to do trim on a server?
Oh, but you see, we have trim support in ZFS in Solaris since quite a long time. It's been added sometimes, so it's not like you have to unplug the drive. It does it. It's like a deferred, trimmed after a race.
Why should you do this?
Well, maybe you should or shouldn't, but that would actually result in a performance degradation curve slightly different from yours here, because it would actually recover some of the performance that a non-trim operation would not show you and would not allow you to access.
Might be true, but this graphic is coming from one guy on an Exentex installation.
But if
so it's based on ZFS, this one. So it's if trim is included, which I didn't know, still this is what you get. Yeah.
What does Fusion do better than you guys?
They time to market, they did it great, absolutely. Marketing, they are no second to anyone. I mean, they know how to, they enable a market, they create a market. We have all the respect to Fusion, to what they did so far. And they invented the market by themselves, by being a startup company. So all the respect to Fusion.io. Their approach is different. I'm not saying that they are taking the wrong approach. I mean, their approach is let's use the host resources to improve performance. Our approach is we know that the host can be limited in resources, so we do everything on our card. So it's two different approaches. I'm not saying that we are the right guy, they are the wrong guy. All the respect to Fusion.io. Are you from Fusion? But there is one thing that we do better, which is the price. Fusion.io is taking advantage of a monopolist situation on the PCIe. In our case, a PCIe is not different than a SAS device. So in terms of dollars per gigabyte, we will position the product at the price parity with the SAS device. That means that it will be a third or a fourth of the price of Fusion.io. So in this respect, we do better. Well, actually, they do better because they get more margin. Any other question? Thank you very much. Thank you.